So our 1.8 talks about perimeters, and then you got to remember the perimeter of a circle has a fancy name, circumference. And then sometimes we'll talk about areas. So I'm going to just write down some formulas for you guys. And you should write these down too. If I have, let's start with squares first. So, by definition, a square has 4 90-degree angles, and every one of the sides is congruent. So this is a square by definition. And if we have a square that has a side length s, then the perimeter is equal to 4 times s, because it's really s plus s plus s plus s. And then the area is just the length times the width, or s squared. Does that make sense? Yeah. Okay, cool. This should be a review for you guys. Let's move on to something else, shall we? Let's do like a rectangle. A rectangle is kind of like a square. It has 4 90-degree angles, but it has 2 parallel line segments, but the line segments, they're only 2 sets of congruent. Not all 4 of them are congruent, only 2 sets of congruent. And on this one, we sometimes refer to this as the height, and we refer to this as the base. And so if that's the case, then the perimeter, this is just a rectangle. And so our perimeter would be 2 times b plus 2 times h. Another way that you could write that would be like 2 times b plus h. All right, now the area of this thing is really easy. It's just b times h. That's pretty easy, right? Nothing up my sleeve. Can I move on to the next one? No? Yes? No? Yes? No? Hey, did I ever get that coffee?
Yeah. It's like cold now.
Nah. All right, now can I move on? All right. Let's do triangles. Let's do like a special triangle. That'll work. So for triangles, man, I can't spell today. Triangle. All right, so we want to define a few things on the triangles. The triangles will have what we call an altitude, height. In this particular, the altitude height is going to make a 90-degree angle with the base to the vertex or peak of the triangle. And then from here to here, we call the base. And we could label some things. I suppose we could call this A, and we could call this C. And so the perimeter then would just be the sum of the side lengths, which would be A plus B plus C. The area would be 1/2 times the base times the altitude height. Okay, that's a pretty easy one. Let's do one more. Our friend, the circle. Now, a circle has a radius. Okay. And now this one's a little tricky. The perimeter is really called the circumference, and the circumference is 2 pi r. If this is the radius. Now, if you take the radius and you multiply it by 2, you'll get something known as the diameter. Right? So we would say that the diameter is equal to 2 times r. So really your circumference is just going to be the diameter times pi. And you can think d is equal to 2 times r, right? Does that make sense? All right, so now the area of a circle is just going to be pi r squared. God bless you. And for those of you at home that are curious, where do we get pi from? Well, pi is the relationship of the circumference divided by the diameter. Okay. All right, cool. Now we needed to know that because you're just going to, those are the formulas we're going to use for our homework. Okay? Let's move on to the next one. Can I?
Yes, yeah.
Yeah, okay. So let's do example number 1 out of the textbook. Whoops. I'll read it to you and then we'll draw our pictures and go from there. It says, the botany club members are designing a rectangle garden for the courtyard of your school. They plan to place edging on the outside path. How much edging material will they need? Then they give you some dimensions. So let me draw this out for you guys, and we'll go from there. So they've got this garden, and then inside the garden, they've got edging. Okay? And in your textbook, it's got some dimensions. From here to here, from there to there, it's 4 feet. All right? From here to here, it's 22 feet. Okay? This doesn't look like, right? 4 feet. All right, now that looks better. And then from here to here, 16 feet. Okay? And what they're saying is they want to know, let me reread this, how much they want to place edging on the outside path. Okay? They want to place edging on the outside path, and they want to know how much edging they need. So what we have to do is make a determination. Well, first let's label some things. If this is 4 feet, then from here to here is also 4 feet. And from here to here is also 4 feet. And from here to here is also 4 feet. Okay? And then on the inside you got 22 and 16. So if I wanted to focus on the exterior of this, okay, what would I need to find the perimeter of that? Yes?
Well, you need to know the whole side length, so you need to do 22 plus both 4s to get the whole side.
You are correct, but you're one step ahead of me. What I was going to say is we start with the formula, and it's 2 times the base plus 2 times the height. Now what she was saying is that the height is actually 22 plus 4 plus 4, right? It was 22, then you have 4 up here, and you have 4 down here. And so then our actual height would be 22 plus 8, or 30 feet, right? And then if we do the same thing for our base would be the same, but somebody tell me what I write down there for the base.
60.
that make sense? So now to find the perimeter of this, I'm going to say 2 times the quantity, my base is 24, plus 2 times the height, which is 30. So I've got 48 plus 60, or my perimeter is 108 feet. So if we were to do edging around the perimeter of the outer path, we would need 108 feet.